Good day. This is our lesson 6 for statistics and probability, normal distribution. With competencies, illustrates a normal random variable and its characteristics, and identifies regions under the normal curve corresponding to different standard normal values. Let's construct a table of possible outcomes in a single throw of a pair of dice. So we have here the table for the possible outcomes in throwing a pair of dice for die 1 and die 2 on the upper part. From 1-1 to 1/6, and from 1-1 to 6-1, and from 6-1 to 6-6. So therefore, there are 36 possible outcomes. Get the sum of each outcomes. So we have here the sum for 1 plus 1 is 2, 2 plus 1 is 3, you have 4, 6, 7, and up to 9, 10 with a sum, and 12. So we have here the sum of each outcomes. So from the sum, we're going now to find the probability of each sample space, where in the sample space here is the sum 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have here the sum from 2 to 12. And the probability of getting the sum of 2 is, we have only 1, so that is 1 out of 36. And for the sum of 3, we have 1, 2, so that is 2 out of 36. And for the sum of 4, we have 1, 2, 3, so that's 3 out of 36. And the probability of getting the sum of 5, we have 1, 2, 3, 4, so that is 4 over 36. And for the probability of getting the sum of 6, so we have 1, 2, 3, 4, 5, so that's 5 out of 36. And the probability of getting the sum of 7, we have 6 over 36. And the probability of getting the sum of 8 is 5 out of 36. The probability of getting sum of 9, we have 4 over 36. And for 10, we have 3 over 36. And for 11, we have 2 out of 36. And for the sum of 12 is 1 out of 36. So from the sum and its probability, we're going now to answer or find the median. Median is the middle score of the data. So what is the middle score or middle sum? We have 7, and the middle probability is 6 over 36. So therefore, the median is 7 or 6 over 36 for the probability. Next, what is the mode? Mode is the most number of sum or probability. So the mode for the sum is 7, and mode for the probability is 6 over 36. So therefore, the mode is 7 or 6 over 36. Next, what is the mean? Mean is the average of the sum and average of the probability. So what is the average of the sum? That is 7. And the average of the probability is 6 over 36. So therefore, the mean is 7 or 6 over 36. So therefore, the mean is equal to the median and also equal to the mode, or the mean, median, and mode are all equal. That is 7 and 6 over 36. Now, let's try to make a histogram. So we have here the probability histogram of the sample points of an experiment of getting the sum of 2 unbiased dice in one throw. Wherein for the sum of 7, we have 6 over 36, and that is the mean, median, and mode. And for the sum of 6 and 10, that is 5 over 36. For the sum of 5 and 9, we have 4 over 36, And for the sum of 4 and 10, we have 3 over 36 for the sum of 3 and 11, that is 2 over 36. And for the sum of 2 and 12, we have 1 over 36. So as you can observe, the highest point here is the mean, median, or mode. And both sides of the mean are equal, or the data is equally distributed from the mean. So to sketch the graph for the histogram, so we have here the graph is a bell shape wherein the mean, median, and mode is at the middle, and that is divided into equal or 50% of both sides, 50% data. So we have here the graph of a normal distribution. It's a bell curve, or it's a bell shape. So a normal distribution is the mean, and the mean of the data is the highest point, and the data is clustered around the mean, and the last data is at the end, and the graph is a normal distribution curve. So a normal distribution is, at the middle is the mean, and on the other side is the positive value of standard deviation, and on the left side is the negative value of standard deviation. So a normal probability distribution is a data distribution where the mean, median, and mode are equal, and the distribution is clustered at the center. So the graph of a normal distribution is symmetrical bell-shaped curve. So what are the properties of a normal curve? So first property, the mean, median, and mode are equal and are presented by the central point along the horizontal axis, which determines the highest point of the curve. So mean, median, and mode are equal, which is at the center. Second property, the curve is symmetric around the mean and is asymptotic to the horizontal axis. That is, the curve extends indefinitely in both directions. Third property, the total area or probability under the normal curve is equal to 100% or 1, or 50% or 0.5 to each side from the center. So both sides is divided into 50%, or that is 0.5, with a total area of 100% or 1. Standard score or z-score is the equivalent value of a row score expressed in terms of the mean and standard deviation, the distribution. So we have here the formula, and finding for the z-score is z is equal to row score minus mean divided by the standard deviation, wherein it measures the distance of any particular row score from the mean in standard deviation units. So the formula for equivalent standard deviation of the z-score, where z is equal to row score minus mean divided by the standard deviation. So we have here the normal distribution. So again, at the middle is the mean, which symbolizes mu. And on the right side, the distance is one standard deviation, wherein the area of one standard deviation from the mean is 34.1%. Then next, we have two standard deviation, wherein the area is 13.6%. And for three standard deviation, the area is 2.1%, and the tail of the bell shape is 0.1%. And on the left side of the mean, we have the negative 1 standard deviation, wherein the area is 34.1%. We have negative 2 standard deviation, area is 13.6%. And negative 3 standard deviation, the area is 2.1%, and the tail is 0.1%, with a total area of 100% or 1. So to find for the probability, we're going to use the z table to find the value. We have the negative z table from negative 3.4 to 0 on the left side, and on the upper part is from 0.00 to 0.09. So we have also here the positive z table. On the left side, we have from 0.0 to 3.4, and the upper part from 0.00 to 0.09. So how to use the z table for the positive value of z table? For example, we're going to find the area under the normal curve, that is z is equal to 1.53. So on the left side of the table, we're going to locate 1.5 and the remaining 0.03 at the upper part of the table. Then get the intersection of 1.5 and 0.03, wherein the intersection value is 0.9370. So therefore, the value of z is equal to 1.53 is equal to 0.9370, or that is 93.7%. So therefore, the area of this 1.53 is 93.7%. What about if we're going to find the area under the normal curve from z is equal to 0 to z is equal to 1.53? Z is equal to 0 here is the mean. So we're going to use the same table, same value of 1.53, which is 0.9370. So we have here the graph. Since we're going to find from 0 to 1.53, so therefore we're going to find only this area, 0 to 1.53. So to find this, we need to subtract the half of the bell shape, the data of the bell curve. So that is 50% of the data, or that is 0.5. So we're going to subtract that from the value of 1.53, which is 0.9370. So subtract 0.5. So the value now is 0.4370, or that's equal to 43.7%. So therefore, the area of 1.53 is equal to 43.7% of the data. How to use the z table, which is the negative? So for example, we're going to find the area under the normal curve. Z is equal to negative 1.75. So we have here the bell shape or the normal curve. So using the negative table, so we're going to locate negative 1.7 on the left side and the remaining 0.05 at the upper part of the table. Then get the intersection of negative 1.7 and 0.05, and that is 0.0401. So therefore, the area of negative 1.75 is equal to 0.0401, or that's equal to 4.01%. So this is equivalent now to 4.01%. Another example, we're going to find the area of the region between z is equal to 1 and z is equal to 3. So we have here the graph for z is equal to 1. So using the table, we're going to find the value of z is equal to 1, and that is equal to 0.8413. And the value of z is equal to 1 is 0.8413. And then for z is equal to 3, going now to find the value of z is equal to 3, so that is 0.9987. So the value of z is equal to 3 is 0.9987. Since we're going to find the area between 1 and 3, so therefore we need only this area. So we're going to find the area of 1, 2, 3, between 1 to 3. So to find this, we're going to subtract the value of z is equal to 3, which is 0.9987, and the value of z is equal to 1, which is 0.8413, wherein the difference is 0.1574. So therefore, the area between z is equal to 1 and z is equal to 3 is 15.74%. So therefore, this area is 15.74%, the area between 1 and 3. Number 2, find the area under the normal curve bounded by z is equal to negative 1.23 and z is equal to 0.25. So we have here the graph. So we're going to find this area that is between negative 1.23 and 0.25. So first, we're going to find the value of z is equal to 0.25 using the positive table of z. So that is 0.2 and find 0.05. So we have the intersection as 0.5987. The next, find the value of z is equal to negative 1.23 using the negative table of z. So find negative 1.2. In the upper part, we have 0.03. Then get the intersection. So the value is 0.1093. So given now the value of or the area of z is equal to 0.25 is 0.5987 and the area of z is equal to negative 1.23 is 0.1093. Since we're going to find the area between negative 1.23 and 0.25, so therefore we're going to subtract the area of z is equal to 0.25 and negative 1.23, and that is 0.5987 less 0.1093, which is equal to 0.4894 or 48.94%. So therefore, this area or the area between negative 1.23 and 0.25 is equal to 48.94%. Find the area under the normal curve bounded by z is equal to 1.13 and z is equal to 3.06. So we have here the graph of a normal curve. So that is from 0, we have 1.13 and 3.06. So we're going to find the area between 1.13 and 3.06. So find the area of this part of a normal curve. So first, we're going to find the value of z is equal to 1.13. So using the table, we have 1.1 and find 0.03. So we have the value is 0.8708. And for z is equal to 3.06, find 3. And for the upper part, find 0.06. So we have the value is 0.9989. So therefore, the value of or the area of z is equal to 1.13 is 0.8708. And the area of z is equal to 3.06 is 0.9989. And to find the area between 1.13 and 3.06, we're going to subtract of the two values of z. So that is the z 3.06 is 0.9989 less the value of z 1.13, which is 0.8708, wherein the difference is 0.1281, or that is 12.81%. So therefore, the area between 1.13 and 3.06 is 12.81%. So for your activity, you're going to find the value of the following using the z table. So we have here from number 1 to 10, just use the z table for positive and negative. And then for your activity 2, find the area of the following using the z table and sketch the normal curve. So we have from number 1, 2, 3, 4, and 5. So before we end, let me share this prayer against coronavirus. to protect us, to cover us, and to heal us from this virus and other infection. So again, let's fight against COVID-19. So wear masks and follow the health protocol like social distancing and washing your hand to stay safe. So again, please stay at home. Have a nice day and thank you.